Hello everyone. Today it is my pleasure, together with my students Taylor Vincent and Open Bello, to introduce you to the fantastic world of drilling simulators. And our presentation will try to simplify everything to a level that will make every one of you happy and eager to learn more about what OU is offering in terms of simulators. Our journey will first start with a short history of something is wrong. No, it is. So our journey will first start with a short history of drilling, a history that actually goes back more than 100 years ago. It's actually first drilling process have started relatively simple by digging into the ground until they realized that oil is much deeper than expected, and at that position we are in need of finding other tools and methods to reach our oil and gas. And this, in our history, we can start from 1848, when the first ever modern oil well has been drilled in Asia, Baku. I will call it modern for 1848 because later the wells were drilled with various methods and concepts until to 1901, when Spindletop in Texas had the first ever well drilled using what we call today the rotary drilling. Something very interesting, as of renewable are taking a lot of aspects of our life today. In 1904, the first successful experiment to produce energy from geothermal sources was carried out in Italy, and the good news, it is still active today after more than 115 years. In 1972, the first top drive has been introduced. And the reason I'm insisting here, you can observe that there was a gap of 70 years from the spindle top to have what we consider today to be standard, a top drive. 2011, NOV kindly donates the 3-cyber chair-based drilling simulator to OU. And this is actually our drilling simulator and the core of what we call Drilling Simulation Center of OU, which today in 2020 will have our first virtual webinar, and depending on the feedback, probably will have more than one webinars on this Drilling Simulator Center. How to drill a well, and I will try to do it in a less than 10 seconds, which is very simple. Drilling require 3 major things. You need weight on bit, you need to rotate, and you need to circulate. This will be the science that has been invented in 1901 at Spindletop, Texas, by drilling the first well, applying this process. What have changed from 1901 to 2020? Well, are the tools, the equipment, and the methods we are using today. We can apply weight on bit by using surface vibrations. This is one of the most complex technology that can be used. We can apply the weight on bit using downhole drill collars, thrusters, downhole hammers, and a lot of more complex bottom hole assemblies. We can rotate by using, the classical rotary table. We can use top drive. Remember, since 1972, we are able to do that. But also today, we are rotating the bit by using downhole motors. And nevertheless, pumps, well, a pump is a pump, but the technology have evolved in creating pumps that are capable to run longer, higher power, and we talk here about 6,000 horsepower for pumps. A lot of things have changed, but drilling still stays on rotate, circulate, weight on bit. And because of that, in 2020, we are always welcome our students to embrace our drilling simulator, and in general to embrace simulators. And this is all about why simulators are really needed. Why do we need that? So let me go a little bit back in time. And as you see on the left picture here, back in time, our systems were custom made Wood was the cheapest material, obviously, and they were, a really, I would say, non-standard equipment. Today, equipment becomes more standardized, but also, as you can see on the right picture here, people are working in a total different environment using joysticks in order to operate the rig by avoiding what you see on the left side here, the hard work of, hand operating equipment. And altogether has been done by the engineers trying to improve the working conditions with the main goal, as you can see here, to drill a hole from surface location to subsurface target at the specified depth in a safe and controlled manner. And this aim has been over and over again upgraded every time with new equipment, new system, new concepts. How do we train actually our petroleum engineering workforce for that? How we do that? Petroleum engineering is known for being that type of job that require experience. You need to have experience, and this can only be gained through hands-on. And as the famous Benjamin Franklin have said, tell me and I forget, teach me and I may remember, involve me and I learn. And this is actually all what petroleum engineering is trying to do. There is a lot of training involved in every petroleum engineering aspect. And this training cannot always be done in the field, cannot always be done with real equipment, because that equipment is very expensive and may not be appropriate for people which are just starting to learn. So therefore, simulators are the top of the line learning environment for the new generation. Petroleum engineering did not invent simulators. Simulators were invented in other engineering areas, and particularly, airplane industry is probably the well-known industry to do that. But there were a lot of simulators in other aspects. However, at OU, we are providing our students with the state-of-the-art hands-on experience using various types of simulators. And some of these simulators will have the pleasure to present you here in a short presentation. But of course, later on, if you are interested, please come visit us. You will have a chance to see them. At this point, I will let Taylor to take over and bring you into the detailed world of simulators.
Awesome. Thank you so much. So we started from a very general picture of drilling, a little bit of history, but now if we focus in just on simulators, we're going to do the same thing. We're going to start broad and get very specific down to what we have on campus. I like to look at it just from a word standpoint. So I pulled up this Google book search of basically what simulation or what simulator when it had started appearing. And you can see in 1950, 1960, and 70, computing technology has evolved greatly, and you can see the word even started appearing like crazy. Now, once the internet came, of course, books are moving online. I like to think that the trend would continue, but the idea here is that the word by itself just means to look, feel, or behave like something else. If we look more specifically at the drilling industry, Mr. K.K. Millheim in 1982, he wrote a great paper that focused on simulators just in the drilling industry. The key thing here is that once computing power became more accessible, it's really taking an aim at putting numbers and a logical process into very complex systems and very complex procedures. And so that's really what he helped classify. So we can move on here. And before we get more specific into what they look like and how they work, we still need to get a bit of a framework. And so as Dr. Catalin mentioned, simulators are borrowed from all sorts of different industries, And so there's many types, classification systems for simulators. And I'm going to borrow one from the defense industry, and that's going to be replicated by this first question. How do two systems interact? And we're going to use giving CPR as an example. And then Mr. Millheim is going to help us answer how real is this interaction? And we're going to use stained glass as the example. If you click one here, Dr. Catalan, you can see, so the CPR and the defense industry, they use LVC types. This is for live versus virtual versus a constructive simulation. And Mr. Millheim has 4 different types, and it's basically how specific or how real is the interaction. So let's move forward. So we're going to move on to the CPR example, the LVC. And Dr. Catalan, I first just want to ask you, this is just 2 pictures, no text here. What do you see is, what are the 2 systems, and what do you see differently between live and virtual?
Well, a live session require actually a human being to do the operation. You will have a kind of feedback, but definitively you don't have to break the ribs for a CPR operation, whereas the virtual one allow you to have more sensorics to help you to train to get a much detailed feedback on what you are doing.
Awesome. If you get me one click here, we're going to really spot out the difference, and it's basically just the 2 systems. From a virtual standpoint, what you see here is a real person operating on a simulated system. The system here is basically a user and an environment, and it can take place in real time. We can slow the time down. We can stretch it out. When it comes to the environment, in this case, we see a virtual environment, and this could take place in a classroom or on video camera, but it's an actual, one half of the system is real. And in this case, there is a prop. It's the dummy prop. In the live situation, this is a live simulation. There's a real person on both sides of it. This could happen in regular real time. This could happen at a site where, you know, CPR might need to take place, and it's real equipment, real people. So if we go on, now we're going to compare it to constructive. So again, virtual, real is half real and half simulated. And what we see here in constructive, this is just a video, but it's a video of a program. And this isn't a live link, but the idea here is that in a constructive simulation, it's both sides, both systems are virtual or simulated. So this again could happen in real time or a spaced out time. It could happen in a virtual environment with virtual equipment, and it can very easily be considered a computer program. So this could very easily just be me sitting here at my computer and learning or engaging, learning how to do CPR in a virtual environment. Or it could be someone else, you know, demonstrating for me, and it could be all virtual. So that's this, of course, this classification system was borrowed from the defense industry. So if we move on, we're going to actually move on to our drilling industry. Mr. Millheim. So there's 4 different types, and the first one is a partial task. I want to remind you I'm using the example of stained glass, and here in this picture, you're only seeing a little bit of the picture. What he defines as a partial task simulator is something that's going to just show you one distinct function or one part of the big picture. So these simulators typically are cheaper. Physically, they look simpler, and the mathematics maybe behind them are also a little bit simpler. So if we go on to the next type, move from partial task to a procedural task, and again, our picture expands. We're seeing more of the stained glass. In terms of a simulator, we're going to move from a distinct function to maybe a group of functions, or maybe the entire simulation is just more complex. In these models, both the software and the hardware looks more like what you would expect from a big simulator. We move on to high fidelity, And don't get tripped up by fidelity. This just means the realism is ramping up even more. In the picture, we're seeing we went from black and white to color. And even now we can see color, but we can also see through the stained glass to some sort of environment. So now we might actually be simulating an entire process. It's a very complex thing, a lot of procedures, and it just, again, the level up of simulation is more real. Lastly, he classifies some simulators as being engineering simulators. One key thing here is that not a lot of these exist even in any industry. They're very expensive. They're very, very hard to design and maintain. But what they're really good at is focusing in on a very, very not specific function, but the level of detail in the engineering software and hardware is extremely real. Awesome. Let's move on. So now we're going to get into what do these things look like. And I have just two examples here, and these are both from the company Drilling Systems. But the idea here is that these types that we talked about are taking place even within one company. On the left, you can see a conventional rig floor simulator. These look very realistic. The controls and the panels, it's a little hard to see. If you move the mouse, you can see that there's a handbrake in the background, and there's certain controls that are exactly real. I mean, you can see the weight indicator. And then here in the front is just an instructor panel. So it's basically being able to set up the experiment or the simulation that you intend. On the right, this is a lot of the modern rigs that we're talking about. These are a very immersive environment. You know, it takes 3 dimensions now. You're sitting in real equipment. So again, we're seeing this the breadth of simulator types coming into play. If we move on, we're going to see some simulators from a second company, Endeavor. And again, what I'm trying to explain here is that these are a range of types. The bottom 2 are just on a desk. You know, we're not really sitting inside of anything, but we're still able to simulate certain process of a system, or we're able to use some sort of real equipment. And so we're even going to see that when we move on eventually to see what we have at OU. So we looked at hardware. So we move on, we're going to even see that simulators exist in just a software version or software based. So what are these? What do they look like? Here, just 3 examples. You can see a laptop based simulator from Drilling Systems. Down at the bottom, hey, we can even make simulators that exist on our phones or on our iPads. And you know, I'm going to get into why these are special, but also keep in mind I also like to consider well planning suites. This might be how we design mud programs or directional drilling a well. So I even consider these as simulators for the sense that you can acquire data in the field, you can come back and you can re-simulate your well or your field, and then you can also use all that data to predict your next one. So why are these special? If you click once, then we can see that what's really great about the software versions is that they can be cheaper. They can be easier to maintain. We can update them over time. And for our example for this webinar even is that you can really expose and teach, and they're very convenient to do so. So we're going to move on to what we have at OU, and Dr. Bello is going to take us through the first one.
All right, thank you very much, Taylor. Leveraging the 3 server-based chair donated by NOB, our biggest return of investment here at the Drilling Simulator Center is establishing a quality educational training to our students in preparation for real-life drilling activities like tripping in, tripping out, how you connect pipe, and other related operations. Also, what we also established here with the OU Petroleum Engineering student is to familiarize them with mechanical operation of a drilling rig. As you can see, I'm sitting down in the simulator center here, whereby you can see all series of drilling mechanical equipment. Yeah, like auto rocker, and you can see the drill pipe here. Unfortunately, you cannot see the pipe that is being, in the well center here. And here you can see, the power tongue here. So this is the kind of training that we established to our student. And of course, there will be a follow-up video about this drilling simulator and our training model that will be established or shared on LinkedIn very soon. Thank you.
Something here to mention, our NOV simulator is called also HIL, so-called hardware in the loop simulator, and is the latest type on the market. Hardware in the loop simulators allow you to actually test not only how the people are operating the system, but you can test equipment within the same simulator. So that's why you can see here the HIL simulator from NOV. So I think Taylor will take over for the drilling systems, as he's the expert on that.
Sure. So a little anecdote. I remember when I was doing my undergraduate degree, I took a well control class, and it was industry standard. It happened to be this exact same simulator. And as a student, it was my first exposure to real drilling. And at the time, I walked into the room, I said, this looks like a toy. But after getting a little bit of experience and coming back, and now that I've learned more about it, I realized as a simulator, these things are powerful. You can truly understand a lot about drilling in a safe environment in a classroom. So we've used these to do research, and now, I even simulate some pretty realistic drilling situations on simple consoles. And it's not just drilling. We can design and we can control well control events. This is awesome. We can pick this thing up, we can move it to another classroom and teach more people. If we move on, we can see, we can answer the question, how do we actually use them? I was talking about it a little bit, but we do have a course, we have trainings, we talk about human factors. We talked about the HIL simulator for hardware in the loop, but now that we actually are starting to get more involved and getting people involved, I even like to throw the word human in there, human in the loop. We can really test, we can really train by using hardware, simulation, humans. And some of the research that we're doing is ongoing, and it has been done already. And right now we're doing some on just how do we communicate so we can do that in the simulated environment. One of the experiments I've designed is actually called the Driller's Roadmap. It's using the well control simulator from the previous slide. And basically all I did was I designed 3 different situations where we asked to a driller and an assistant driller, so that's represented by the 2 people at the top. We're recording their voices, but we asked them in the first situation to just talk however you normally would. For instance, the assistant driller might tell the driller, hey, set the rotary speed to 135 revs. And one thing we're doing, we're just seeing how long it takes for them to accomplish these tasks. Of course, we're asking them to do many, many tasks. And a second experiment, we're actually giving them words to say. These are styles of poor communication. We're trying to prove effective communication using a simulator, but here in this example, we say, hey, rotate faster. The driller might say, what do you mean? Or the assistant driller might say, increase the rotary by 35. What we've already discovered is that by having random or poor communication, they're sometimes not even achieving the task. Or if they are achieving the task, it's taking much, much longer time, and then there's usually extra verbiage, extra words that are not necessarily needing to be used. In a real life situation, we have safety on the line. This is a big deal. In a third experiment, we're actually giving them a script. We're saying, hey, do exactly this. So instead of the ambiguous, now we're saying increase the RPM to 135. And what we've seen is that all of the results, everyone's accomplishing the task, and they're doing it much faster in an efficient way. Dr. Catalan's going to talk about another research project that has gone on.
So this is a project that has been actually integrating a lot of other engineering aspects, you know, mechanical engineering, eye tracking technology, which is highly used in other industries, down to, you know, psychology and understanding of the human behavior in as such. The project here particularly was trying to look at what are the data, the parameter that a human being is focusing on and the human being is able to capture within a given time. It's nothing new, has been done massively for training pilots and to optimize how many, you know, details a pilot should have in front of him to take better decisions. But for oil and gas, this was relatively new, and the results, we have few papers published, were really amazing on this part. But last but not least, we do actually have simulators all over the place. Simulators can be very simple setups, very simple systems that are helping us to understand one part of our reality. And that part could be complex or could be simplified just to look at that simple effect. One of the things, for example, we have at OU is our drill string vibration laboratory. It is, to my understanding, well, not because I built it, but to my understanding, it is the largest stick slip simulator in the world. It is 50 feet tall and allow us to understand how the drill string behave under dynamic conditions. For those of you interested in that, we'll have a video soon on LinkedIn. So you are welcome, you know, to get in contact with me and obviously my two students, Taylor and Dr. Bello, and you know, you will get the latest feeds that we will post on LinkedIn. On the other hand, I must mention I'm very proud of OU students because we've been able to win several times the first place in what is called SP Drill Botics competition. And we have built another simulator. It's nothing else than a drilling rig that is designed to mimic automation. It's designed to mimic how a drilling rig can autonomously drill a well without a permanent input for the human being. So what the drill botics aim is do is you press a button and you tell the drilling rig, drill to that depth with that speed the well, and that's what the drilling rig is doing. And as I said, amazing students we have here, and they've been able to win several times the first and second place, but I think first place is what counts all the time in our presentations. I think at this point, it's my time to draw some conclusions for everyone. And, you know, I've been teaching drilling for almost 20 years. And I always insist drilling is simple to its core, rotate, circulate, wait a bit. But in the same time, we have evolved massively into the digital operations, into this complexity of human-machine interaction. The times where the drillers were involved in lifting heavy equipment are moving now to the press of a button and operating a joystick. The simulators have obviously evolved in parallel to meet the demand of the time, and particularly today to meet the complexity of a drilling rig. If you remember the wooden rig versus the modern joystick rig, believe me, the amount of parameter a human being have to deal with has been about 100 times more in this case. We have been able to present you a wide range of simulators, and I hope you understand, you know, complexity of the simulator and why different simulators has been built, why different simulators exist on the market, because they are designed by type, application, convenience, affordability, and of course, whether they are just software, pure software, or hardware. In times like this, obviously, a hardware system will have limitation because you cannot have too many people in that room, whereas the software will be kind of unlimited in terms of operation. Our simulators, what we have to you, both the hardware as well as the software, are highly valuable for research, but also the results we have generated have shown that there is much more to do. And I believe that future is still in our hands. Whether you want to use just a handbrake, believe me, there are about 60% of all drilling rigs on the market, or you gently want to push a joystick, either way, you have to go through a simulator first to get all the certification you need in order to be allowed to push that joystick. And with all of this, I will like to conclude our system. I would like to invite all of you to watch our LinkedIn page, either myself or my students, and there will be some virtual tours videos of our drilling simulator center. Each one of our simulators will be presented in a kind of a 5-minute presentation. At this stage, I would like to thank again my students, Taylor, for amazing work in this simulator world and the way, we created this PowerPoint. To Dr. Bello for particularly keeping our NOV simulator up and running, and for the videos that will come to do that. And at this point, I will basically shut down the PowerPoint, the share screen, and I will move back to our question and answer system where we can see the video of everyone. So I believe now that
I'd like to thank you all for joining us. Absolutely.